Hi, I want to talk about KogsChain, which is a blockchain that we've written at MIT for private blockchain networks. And we have smart contracts and a few other things that make it ideal for, we think, for the Internet of Things area and companies such as utilities, oil and gas. So let's take a quick look at what we've done. So I believe you're all familiar with the idea of creating a blockchain. And so we lock in transactions by using hashes, and as blocks are added, these blocks become immutable in the sense that it would take an attacker too much effort and time to recalculate and fake all the hashes. And so what I'm going to show you what I want to show you today is we're going to be throwing up three nodes that will be miners and will mine blocks in the blockchain. And so, for example, the typical situation would be that node 1 has just mined block 2. The other two nodes are mining away but haven't mined a block yet. And so now node 1 broadcasts out to the other nodes that it has a new block to add. Those nodes check that it's a legitimate block, and if so, they add it to their blockchain. And it's in their interest to do this. And we can talk exactly about how we arrange that the software, in fact, will attach these blocks and keep all the blocks synchronized. So that's what we've got. Let's just show you the interface to this. Here's our KogsChain. And we are going to mine a block, and in this case John is going to send 33 coins to Abel. But we have a smart contract capability, and here we say if coin transaction is less than 100, 100 is the minimum, so we're going to force that John sends Abel 100 coins. This is just fictitious, but let's actually just say if it's less than 50, which it is, we'll send 50. Return 50, and if it's less than 50, let's just do that just to show you that this is live. Return 50 if it's less than 50. Okay. So that's our smart contract. Now let's go and I want to take you to, so what I'm going to do is I'm going to get into a window here. You see I'm just going to check what state I'm in here. Minus A, minus Q. No, I don't have any Docker containers running. Let me look at my Docker images. I have one Docker image node. I'm going to do Docker compose and put up 3 Docker containers, each with a node in it. So we'll build this. Okay, we've got the 3 nodes up and running, and we've got our Genesis block in each, and we can take a look at, we can communicate with these nodes, these 3 nodes. So for example, I happen to know that one is running on local host 3031, and if I do blocks, it'll tell me, yep, that one has those blocks. It's just the Genesis block. And if I look at 2, it has the same thing, and 3. So we can communicate with these servers. So each of the nodes has got its own web server running, and we can generate blocks via that web server. In this case, I'm going to go to my user interface, which is running, and let's go and mine a block, and let me show you it being mined. So here we are. here's our blockchain, and let me bring over this, and I'll execute this and say if the coin is less than 50, return 50. So it is less than 50, so we expect John to send Abel 50. So there it is being mined, and if we look into the state of the blocks, here we'll see that 50 coins, John sent Abel 50 coins. And again, if we now hit let's go to this local host, now we'll see, yep, we've got another block added. That's how we create the blockchain and control it. So that's how we do the smart contracts, and we'll come back and show you some of the code for this in another video.